Hello, students. Yesterday, we talked about the periodic table and learned a little bit about the history of the periodic table and discovered the differences between Mendeleev's periodic table and Moseley's periodic table. Do any of you remember how did Dmitri Mendeleev arrange his periodic table? According to atomic mass. And how did Henry Moseley arrange his periodic table? According to atomic number. Very good. And so today we're going to pick up with the periodic table and we're going to learn a little bit more about how the periodic table is structured. And this is important information for us to learn and listen to and remember, because we are going to depend on this periodic table again as a tool, basically, for the rest of the year. I don't ask you to memorize the entire periodic table, but I do expect you to learn and know how to use the periodic table. So let's get right into it here. Let's begin with the columns. The columns on the periodic table have a couple names. We call them groups or families. Groups or families go up and down on the periodic table. And I have a question for you. I don't know if any of you have relatives that are blood relatives. You are genetically related to them. But do any of you ever had, let's say, a family reunion at some point in your life? And maybe you've got some long lost aunt that you don't even know and you don't even remember ever seeing, but they know you, and they come up to you and look at you with a scary grin on their face and grab a hold of you by the cheeks and say, "Oh, you look just like your father when he was your age." And it kind of freaks you out. Have any of you ever experienced something like that? Or have any of you ever experienced someone ever looking at you and making an observation saying that you look like one of your siblings or you look like your parent, and you deny it and say, "No, I don't"? I come from a family of 7 kids. I've got dozens, if not hundreds of relatives, cousins rather, and certainly hundreds of relatives. I have heard those things in my life, especially when I was younger, believe me. But why do people say such things? Do they say it just to annoy you? Well, maybe some might. But do you think there might be some element of truth in their observation? Could it be possible that maybe there are similar characteristics between you and others you are genetically related to? I think it could be. And it's the same with the periodic table. Groups or families of elements have similar characteristics or properties to one another. So when you look at a periodic table and you see, for instance, elements that are above and below one another, it is because they have similar characteristics or properties. You could say they are related to one another, which is why we call them families of elements. So think about that as we go through. And it's those characteristics, those properties that both Mendeleev and Moseley were recognizing and identifying as they were arranging their element cards into a periodic table. Not unlike we arrange days of the week on a calendar, and after the end of the week, we start over with the next week. Because if you look at a calendar, all the days that are above or below one another are the same day of the week. Think about it. Okay? Same idea with a periodic table. Now, horizontally on a periodic table are rows. And these rows, row your boat gently down the stream. Merrily, 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 life is but a dream. I don't know why I sang that, but row. We row down a river horizontally with the river. Maybe that'll help you remember that rows go this way. Columns go up and down, like the columns of the Colosseum go up and down. Back to the rows. These horizontal rows are called periods. And the periods are like the weeks in a calendar. These different colored areas represent different periods of the periodic table. They go horizontally. Now, sometimes back in the old days, if you had a family portrait, you might actually have had your family lined up by age order, the youngest on one side and the oldest on the other side. Or there's a famous movie from the 60s called The Sound of Music. The hills are alive with the sound of music. Oh, maybe you've seen that. One of my favorite movies. It's actually a great musical. If you've never seen it, you should see it. But it talks about the Von Trapp family. And by the way, it's based on a true story. And the Von Trapp family, they had what'd they have, like 7 kids? And the father used to line them up in height order. When you're ready to be promoted from 8th grade, you might have an 8th grade class picture taken. And your class picture, the photographer might arrange you according to height order. It's typically done during the graduation ceremony as well. Well, why do I mention that? Well, the periods on a periodic table are arranged according to the valence number increasing from left to right. What in the world does that mean? Am I scaring you? I've introduced another word here, valence. I'll talk about it in a moment. But basically, what it means for our purposes right now is that the elements get bigger. From left to right on a periodic table, the smaller elements are on the left, the bigger elements are on the right. So it's like a photographer arranging a family for a family portrait. All the little guys go to the left, all the big guys go to the right, basically. All right. Now, let's get to this word, valence number. This, as we will discover, is probably the single most important concept in chemistry. So if you've been dozing a little bit with my singing, I'd like to wake you up. Ooh, yeah, wake up right now, because this is the single most important point that you need to grasp in chemistry, because just about everything else is based on this point. And what is this point? Well, it has to do with the valence number. I've told you in the past that L electrons are important. Well, this is where the importance starts here. The valence number describes the number of electrons in the outermost energy level. You may recall from our previous topic on the atoms, we learned that the protons, neutrons, electrons are subatomic particles. The protons and the neutrons are found in the nucleus, and the electrons are found orbiting around the nucleus. I also mentioned to you at that time that we would be using the Niels Bohr model of atoms. This is a Niels Bohr, this is a Bohrian model of an atom where we have electrons in orbits. When you get to high school, you'll learn it's a lot more complex than this, but understanding this orbital concept at this level is going to help you tremendously later on. and it's going to definitely help us understand a lot of important things as we continue our study of chemistry. But back to the valence number. Valence number is the number of electrons in the outermost energy level. So here in this atom, we've got nucleus in red, and we've got the first energy level surrounded by the second energy level. How many electrons are in the second or the outermost energy level? I hope you can see that the number is 1. There's only 1 electron in the outermost energy level of this diagram. What does that mean? Well, you'll learn that that means that this element, no matter what it is, if it has 1 electron in its outer energy level, it's going to have similar properties or characteristics to other elements that have 1 electron in its outer energy level. In other words, the elements that are in a family with one another, and let me just go back to the families here, the elements that are above and below one another in a periodic table, I'll tell you right now, all of these elements in this first group of family, they all have 1 valence electron, all of them. The second group of elements, group 2, all of those elements have 2 electrons in their outer energy level, or 2 valence electrons. Now, I'll explain that this lower part is a little bit different, but it picks up over here. These all have 4 valence electrons, 5 valence electrons, 6 valence electrons, 7 valence electrons, 6 valence electrons, 7 valence electrons, and 8 valence electrons. 8 is a magic number in chemistry. Now, we'll get to helium later. That's a little bit different, but know that these other elements in the last group all have 8 valence electrons. That's why they have similar characteristics or properties to one another. That's what makes them part of the same family. Now, in addition to those characteristics within the groups and within the rows, there are other divisions in the periodic table that you should be aware of. I've mentioned this in the past, but here's a good time for us to really come to grasp with it. All of the elements on the left side of the periodic table are the metals. All metals in the periodic table are to the left. All non-metals on the periodic table are to the right. And the thing that divides them is that boulder staircase, which is comprised of elements called metalloids, which have characteristics of both metals and or non-metals, depending upon what it might be near. So metals on the left, non-metals on the right. That's going to be really important. Actually, all of this is really important this week. So be sure to study this topic on the periodic table. A couple more things and then we'll be finished up. In the periodic table in your book, I want you to notice the titles of each of the families. And you may have to turn the page to see the periodic table in your book, but notice that on the top of each column should be placed Roman numerals and letters. On top of the first column, group 1A. Second column, group 2A. All of these lower elements we're going to label B. They're part of the B team for now. Then over to the B, which stands for boron. We have group 3A, carbon, 4A, nitrogen, 5A, oxygen, 6A, fluorine, 7A, and at the top of the helium, you should write 8A. And then down on the bottom, we've got RE for the rare earth elements. Now, I just want to emphasize this again, even though I alluded to it earlier. The group number here, the group number, like group 1A, that group number, number 1, refers to the number of valence electrons of all of the members of that family or group. So all of these elements, group 1A, how many valence electrons do they have? 1. So how many valence electrons does lithium have? How about sodium? How about potassium? How about rubidium, cesium, francium? All of these elements have 1 electron in their outermost energy level. Let's go over to the other side of the periodic table. And I'm going to skip over helium for now. We'll find out why in a moment. But neon, argon, krypton, xenon, radon. How many valence electrons do you think those elements have? 8. They're in group 8. They have 8. Another way of thinking of it is their outermost energy level is filled. And that phrase will help us understand helium later, because helium only has 2 electrons in its outermost energy level, but its outermost energy level is filled because it only has 1 energy level. Again, don't panic about that. We'll talk more about it later. All right. Finally, what I'd like us to focus on right now is this. I wish I could show you in person, but I can't right now. I have little video clips for examples of each of these different families of elements. And so for the remainder of the time, what I'd like you to do is check out the videos here that I have links to describing the characteristics of some of these element families. You're going to start with my favorites here, the alkali metals. You will see why they are highly reactive. Watch the rest of these group as well. And also in your book, you'll find a place where you should write down these descriptions of the family names. So for the remainder of the time, check out the video clips and see what your favorite family is as well. And maybe we'll have a family feud later on. But for now, I'm going to leave you there for now. Enjoy the videos. Bye-bye.